Okay, now what we wanted to do is you can be able now to like do the gymnastics. You can actually plot like here age x. Okay, you can plot it by maybe LX. So when you plot it against that, you have a graph of that sort, and then when you plot like QX and you plot it against age, okay, you can actually have a curve which can actually go like that. And at the same time, if you want to plot the depth dx and by age, okay, age x, in this case you can actually have a situation which can be appear like this. And then if you take a logarithm, a log of qx, then the curve normally changes and the curve becomes like this. So it goes in that particular part because it's a log qx function. So this is actually the way we can be able to actually plot. Now I want us to actually think of a situation to say, since I don't have enough space, I will still be labeling at the bottom and then determine the values, or let me take this part. Now, so the question can be, let me just separate here. The question can be, what is the proportion of men aged 31 expected to live to age 35. Okay, proportion of men aged 31 expected to live up to age 35. So in this case, you'll be able to have L35 divided by L31. So this is actually the proportion. So in this case, you actually look at the difference. These were the people that were aged 31 and are expected to live up to age 35. So that's the proportion. So in this case, you can actually look at how many people are up to age 35 is 95,000. Okay, is 95,000 and the 598. And how many people were aged 31? So those ones were 96,000 and 086. So this is actually the proportion that we can be able to have. So at the end of the day, if you divide the values in that particular process, you can actually have a value of 0.99492. So this is actually the proportion. So this is the proportion that is defining the survivorship of men from age 31 to age 35. So looking at that, you can actually now determine the survivorship from any age. So from this age to that age, 35, from 30 maybe to 33, from 30 maybe to 35, by just dividing the number of years lived with regards to that. So it means that if we have got 10,000 people, that are in a particular area, so we can, if we take this 10,000 and multiply by this population, this probability, we can actually calculate the actual number that could survive to that particular age. So that's the most important aspect we can be able to take note of with regards to the calculations. So LX can be very much important because it can give us some important hints as to how we can understand some of the calculations of interest. And similarly, we can be able to calculate the proportion of male now aged 32 who will die while aged 34th birthday, last birthday. Okay, so in this case, the proportion is D34. These are the people that will die at the last birthday at the age of 34. But the people that are aged 32 at that moment is L32. So it means that this proportion it is going to give us the male aged 32 who will die while aged 34, because we have taken the people that have died into that particular context. So if you take the calculations there, you will take 126 divided by 95,966, and then the proportion of dying is actually 0.00131. So it means that people can actually experience that particular probability. So it means that if we can know how many people can die in the year, like next year, and we can easily calculate the probability of dying of anyone to that particular year. And if we have celebrated the next birthday, we are just happy that we are celebrating that birthday. But normally we can be, it's just by luck. So it means that that probability, it shifts to the other period. So that's the most important aspect. And on the other part is we can easily calculate the average number of people, the average or the mean number of people, average number of people who might be expected to die between age 31 and the age 35 out of 3,000 males, okay, now aged 30. Can you see that? So we have got quite a number of variations in that particular part. So we are saying average number of people who are now aged 31 and this particular are expected to live up to age 35, but at the moment they are out of 3,000 people, and at this moment they are aged 30. So in this case, we can actually say probability, it can be those that are aged 31 and from age 35, and then we can be able to take L30, okay, because this one, it is talking about the people that are aged 30, that are aged 31, who are expected to live up to age 35, but now they are now aged 30, okay, and in total there are 3,000 people. So you multiply by 3,000, so that in that particular process you are able now to determine the value. So the value that can be obtained, it could be, so you take 3,000 multiplied by L35 minus L35. So you take what is L35, this value. So you take minus L31, then you divide by that particular value. So once you do that, you are able to get the value, and the value is approximately 15. So we have got approximately 15 people who are expected to actually die within that particular moment. Okay, so we are going to continue on the same, so that you can be able to actually determine some calculations pertaining to that. But I hope you'll be able to take it slowly, so that you can understand the connotation behind this particular problem. And you can actually refer to a book which is called Pollard, and I'm teaching on page 35 to actually page 39. This is where some of these problems are actually indicated. We are continuing in the next session.